Okay, so hello everybody. We'll get this session underway in a couple of minutes. What I'm planning to do today is to go through some examples of writing up an experimental or observational study design. So that's pretty much what I want to focus on, and then if there's time at the end, if anybody has any extra questions, should be plenty of time to ask. I had wanted to do them last week, or at least get onto the first one, but we kind of ran out of time because we did the brainstorming exercise. But anyway, we're going to start with this, so hopefully you find it useful. The idea is going to be that we look at a sample experimental design, pull it apart, figure out what's wrong with it, and then try and rewrite it into something better. So hopefully you'll find that fairly useful. I think what we'll do, it will help you look at your own study designs and look at them critically, and therefore see how you can improve your own ones. So that's the idea. And I kind of feel that there's been a bit of a lack of examples in the notes on how to set one up. So I think this sort of fulfills that purpose. So everyone pretty much ready to start, or any quick questions before we get started? Okay. Maybe someone else could, if they feel ready, they could go into the other room and see if there's anybody hanging out in the other room. Okay, David asked a question, would you be able to get feedback prior to the due date? And the answer to that is no. I kind of thought I made clear in week one that we don't give feedback prior to it being assessed. It's a challenging assignment. It's not easy. But to give feedback to some students and not others, you know, wouldn't be fair. And the other thing is too that you know, that if somebody posts something on the discussion forum, then, you know, a tutor might see this and say, oh yeah, that looks all right. And then later it might turn out it's not. So we kind of prefer not to do that. Okay, so quick one, Danilo said no sound yet. Everyone else has sound? Can hear me? I think they can. Yep, most people do. So just check your own, that you've got your own sound turned up. I increased my speed over the week too, just in case that was a problem. So I'm now on faster internet for a little while. So hopefully that'll help. David said, I did submit mine earlier today. If you change your mind about anything through this session or whatever, you can resubmit, not a problem. You don't even have to tell us. We just, when there's multiple submissions, we just look at the last one. I think in other courses they haven't had that, and it just creates a lot of extra work for the tutors. People leaving assessment, and yeah, just difficult. So we always make them multiple submissions. But we only look at the last one. If for some strange reason that you submit one accidentally and you don't want us to look at the last one, if you let us know, then we won't do that. But otherwise, if we're not told, then we just look at the last one. And we don't look at anything earlier. We just don't touch it. So it doesn't matter how stupid it is. We don't care because we don't look at it. Okay. So let's get underway. If you've downloaded the assessment, which I assume everybody's done, you'll see that at first there's a bit of a basic description, fairly broad description, and then notice in red your submission should fit onto one A4 page only. And then there's the rubric. This is actually a bit of an older version. I've updated that. So Number 3 should say the sample size and the sampling process. So what we require you to do here is describe how you're doing your sample, how you're constructing it, not just the size. The size we want to know about, not so much, we don't really care how you've decided the size. You don't have to justify it, but if we spot, oh, you've chosen a size that looks too small or for some reason is too big, then we can comment on that for you. Okay. So pay attention to the way you submit your files. We're kind of a bit strict about this because the way we mark it is we download everybody's submission and then put it in a folder and then go and mark it offline. I find that much easier. I can't read them properly online. My eyes aren't good enough. So if somebody doesn't put their name in the file name, then it then makes it hard to see who they are. So you should put your name in the file name, and you should also put it at the top of your document. I don't care whether it's a header or footer. I don't really care whether it's a student number or not, because I've looked at all the names and there's no names that are the same. So you can do it as a header or a footer. You can do it just as a title. That's up to you. But remember, it's only one page. Don't do a cover page. You won't lose any marks if you do a cover page, but it's just annoying for us to have to scroll to the next page. So yeah, just one page is all that's necessary. And you'll see today, when we go through some examples, one page is more than enough to answer the question. Okay, now what I'm basically on about today is these 3 examples that were included in the assignment itself. Now, I want to pull them apart and describe them and put them back together again as best I can, because I think that's a useful thing to do. So there was one that was on investigating a student survey. We'll probably spend the most time on that one because it was a pretty poor one, actually, and you'll see why. Another one was somebody was looking at internet speed, and a third one, testing a new drug's effectiveness. Now, I didn't come up with these. One of the other tutors did, who's not a tutor this year. Okay, and sorry, Steph. Well, there's no point in answering. You can't see or hear anything. Yeah. So I didn't come up with these, so I don't know where they came from. I think they were the ones that Sam, the tutor last year, maybe they were the ones that were marked in the first version of the course. They look like the ones that students have submitted, and I think also included some of the feedback that he gave. Okay. Right. Anyway, so if you've got these in front of you, good. If you don't, I've got them on another slide, and we'll kind of go through and read through them. So each one, they've kind of put a research question and some of the things that are included in the rubric. Most of them haven't included all of them, so they would have lost marks because they didn't address every point in the rubric. So even if something's not applicable, you have to address it. I'm going to go off this slide in a minute, so into something that's easy to read. So yeah, fine. Just wanted to give you an overview, so you don't. Yeah, we'll read it more specifically in a second. So let me do that now. So just got to swap screens. Looks like the one. Okay. How's that now? Can people see that okay? I think that's probably better, easier to read. Yep. Okay, good. Okay, so this first example was some sort of a student survey. This is the original version. So let's kind of pull it apart. Let's read through it. The research question: I want to investigate a student satisfaction survey about a maths subject to see if there's anything about the subject that needs improvement. So what do you think about that as a research question? If you've read the stuff, you'll probably know the answer to that, but what do people think? Yeah, vague is my description as well, Jennifer. It's too vague. Yeah, I want to find out about something. Yeah, and the other thing is it's not really a question either. So it's not saying what they really are investigating. Anything about the subject. Yeah, it's not precise enough. So that's really the major problem with this. What are some other problems? David says, how explicit should we be? Very explicit. It should be really clear. What are you investigating? And the other thing is the research question should include what the population is normally. Somebody there's got their microphone on. Can they turn it off? Good, that's better. Okay. So the research question definitely needs improvement. Now, to fix this up, it's pretty hard because we don't know what was in the mind of the person, so we've just got to guess. Okay, so David asked a question, would a reference to room temperature be too vague? What's that got to do with room temperature? This is a student survey. Are you looking at the same thing I'm looking at? I'm confused about that. But we're talking about this question at the moment. Okay. Okay, so first thing is I'm not allowed to answer questions about specific projects. I can only answer questions in general. Okay, so you're asking in reference to how explicit we need be. So you'll see in a second with this example how explicit it needs to be when we get down to an answer. That's the best I can do. I can't answer your question because it's your assignment and your project. So the one thing I'm not allowed to do, and they're very strict about this, is I'm not allowed to tell you your project, something about your project is right or wrong. We do that when we mark it. So yeah, let's focus on this example. That's what we're talking about. So yeah, so it's hard to know what the answer is because we don't know what was completely in the mind of the person, but we'll do our best. So we'll get to that in a second. Look, what other things do we see about this that could be problematic? Anything else that looks strange to you? Variables aren't clear. Yeah, they're not clear. I agree with that. Yeah, that's the really good one. Michael's pointed out the population is the sample size, or the population is the sample. It can't be. Population, the sample's always got to be smaller than the population. That's what the whole thing is about. You take a sample to try and infer something about the population. Yeah, there was nothing mentioned about the sampling method. Didn't really define the sample. Yeah, just said the numbers. But to be fair, that was probably because that was in the rubric. But we want you now to actually define how you do the sample. But yeah, it looks like it was just a voluntary survey that somebody handed out in the class and 129 people handed it back. Okay, yeah, population. So what is it, a school or a lecture? Is it, yeah, are they trying to say something more general? Is it all subjects? But it can't be. Yeah, it's you have to kind of see what are you taking the sample from. That's your population. All math students, yeah, I think that wouldn't be correct to say all math students. Can everyone see why that wouldn't be correct? They've taken a sample, looks like from a subject. Okay, so so that subject would be the list of students who are doing that subject, probably in that year. So yeah, multiple math subjects, no, because they're not taking a sample from multiple math subjects. It looks like they're taking it from, looks like it was from one class, but it could be from several. Again, they're not clear. So the population here would be that 129 students who completed the survey. Okay, that's what David said. Do people agree or don't agree with that? Yeah, I don't agree with that at all. It's not right. 129 took the survey, but it was from 200 people. So the population looks like it was that 200 people, which is probably the people in the lecture, probably in a lecture. Yeah, so that's the population. 129 people, that's the sample. It's a pretty big sample, and it's too big, really. Samples shouldn't really be big. Generally speaking, your sample shouldn't be bigger than 10% of your population. If it is, you run into problems because your sampling then is not independent. Because generally you're doing sampling without replacement. You're taking somebody and then you're not putting them back again. So the first person you pick out is got a certain probability. The next person you put out would then have a slightly different probability, slightly less, because you're taking from a group that's one less, and then the next one again. So it's not completely independent. But if your sample size is smaller than about 10%, that the difference is pretty small. It's very unlikely that you would, if you were picking things randomly, that you would pick the same person twice. And that's what all the methods assume, is that you're doing sampling with replacement, but in practice, everybody does sampling without replacement. Nobody in a survey wants to get surveyed twice. So you're almost exclusively, there may be some exemptions, but when you're doing sampling, you're usually doing it with, without replacing. Okay, Nicholas asked a question, good question. Would it be okay to have population over several years and use 1 year as the sample? What do people think? Yeah, I agree with David. I would be very worried about that. Reason, maybe you're randomly selecting the year. So, but what's the experimental unit? The year, or are you talking about elements within? If you're talking about elements within, then you're not taking a random sample of the whole population then. So the way around that is you would define your population to be just that year. If you're serious and you want to make some conclusion about several years worth of data, then you should sample from that several years worth of data. Otherwise, your inference is only for the 1 year. So these are the things. This is what makes this project hard. You've got to have a really clear understanding of how to do a sample. And a lot of people get it wrong. Okay, so Kerry asked, is there a way to make it work? Which one? The taking it from 1 year? Okay, yeah, the way to make it work is redefine your population to be that year. That's the way to make it work. So more often than not, you can fix things up by redefining your population. James asked, I talked about infinite populations, chemical reactions. Should we explicitly use the infinite? If you're doing that type of study, yeah, you can say my population is all possible measurements of this experiment, not just the ones that you've done, all possible ones, and you can say bracket infinite size. So that's fine. Nicholas said, what if the question is the ideal time of year to buy something? Well, I'll let you think about that. You know, if it's ideal, then define your population. I'm not going to tell you the answer because it sounds like it's probably your project, but just generally, you know, you're looking, if possible, you want to do a random sample because that helps eliminate bias. But sometimes you can't. But then you have to then argue about why it's close to a random sample. Now, if you just pick a year, that's not random at all. So that I wouldn't, anybody who tried to quote any statistics from that, I wouldn't believe them. I wouldn't believe a single thing about it. Okay, Tom, if you had 5 years of data and you took a stratified sample, okay, from the point of view of this assessment, that's probably valid to do that. From the point of view of a capstone, none of the methods that we're going to teach you work with stratified samples. So unless you really know what you're doing and you know how to modify the methods or how to adjust them, I wouldn't do it. I would just take a simple random sample. So that's up to you. But from the point of view of this assignment, you're not meant to know anything about the statistical methods yet and their assumptions. So we're not going to mark somebody down who uses a valid approach, even if it's not applicable to the capstone. We'll just tell you that you have to do something different for the capstone. Okay. All right, so we've picked a few things that are wrong. There are no groupings of students within the data. That appears to be correct. Sampling error and bias. The survey is promoted heavily within the subject to ensure as many students as possible take it. I don't see that has anything to do with sampling error and bias. Irrelevant. So that would get 0 marks because it doesn't say anything about bias. So the person who did this didn't understand what bias is in a statistical sense. Daniel said, is it biased because they're undertaking maths? What do people think about that? What's your population? If your population's this maths class, then it's got nothing to do with it. So you really got to understand this stuff. And, you know, you should have been asking these questions as we went along rather than just wait for the assignment. But, you know, as you go through the notes, you've really got to understand things well. I've tried to ask a couple of extra questions to try and prompt people to do that. But yeah, so David said, yeah, no, because the math subject is the population. That's correct. So it's not creating bias. Okay, so let's have a look at an attempt now to improve my first attempt at improving this one. So I'll just say main problems with this design. The research questions, poorly designed, that's the worst problem. Variables weren't clear. I didn't really know what they want. And they said, oh, the other thing is they said the rating is ordinal. Yeah, sorry, they said the rating's nominal, but it was ordinal. A rating of a lecturer, 1 to 7, that's not a nominal variable, that's an ordinal variable. And as it turns out, we can consider that as a continuous variable at a stretch anyway, if we wish to do the analysis. Another problem, I think, is too many variables. They've almost chosen, like, there's kind of like 7 different research questions in here, really, or more than 7. There's a lot of variables to analyse, so you have to, one of the most common feedback we give to people in this assignment for their capstones is simplify, simplify. What you're doing is going to be far too complicated to explain in 4 pages. Okay, Lisa said, since there are no groupings, would you need to explain why? Yes, because you have to address the rubric. So just, yeah, there are no groupings because there are no explanatory variables, basically. Would this need to be part of the submission? Yes, it does. Because we can't judge whether you considered it. If you just leave it blank, we don't know whether you considered it or not considered it. So you have to address everything. So if there are no groupings, you should say why. I think it actually says that in the rubric. Okay, I'll say again, this is a hard assignment. It's not easy. May not get it all right, but that's fine. Just do your best with it that you can. Particularly the latter elements of the rubric are kind of a bit harder to do. So make sure you get the early ones right. Sure, and then try on the others. Okay, let's have a look at my first attempt at improved version, but still not great. But this would be an acceptable one for assessment 2A, I think, in most cases. So here I've tried to address all of the rubric elements. So my research question is the one that Sam suggested. What did students like most about this maths subject in 2009? Okay, I still have a bit of, when I mark these things, I look ahead to the capstone, and I still have a few problems with that in terms of the variables and how am I, what statistical test am I going to use? But of course, it's hard for you to do that. I did put out, I don't know if everybody saw it, but I did put a posting which is sort of like a summary of all the statistical methods that you will learn, that you can kind of look, so that while you're waiting for feedback on this capstone, you can say, well, you can have a look at that and say, I think my data will be best served by doing this type of statistical test. And then you can just go to that section and read a bit more about it in the notes, rather than trying to read the whole notes in advance and trying to decide, what you're going to do. So we're not going to tell you what you're going to do. When we give the feedback, that's not our job. That's for you to decide in the capstone. But we will point out if there are kind of problems like it being too complicated or that we can't see, how you're going to analyse this. But we won't mark that wrong. I posted it, I think last week. Might have been late last week I posted that one. It was about a 6-page document. So I go through every method and I give a sort of like a sample of data, so you can kind of see the type of data that it uses. We give suggestions for how to fix to make it work. If there's a big problem, we'll give, with your design, we'll give suggestions to try and how to fix it as best we can. Yes, that's Simo. That's the exact document. It's called subnotes-stattests.pdf. You can have a look. I think they recommend that balance is good from the point of view of precision, but sometimes you can't get a balanced study. You do have uneven sample sizes. That can usually be handled pretty well by a t-test, even simple t-test. Everything that we do, I'm pretty sure everything that we do requires a simple random sample as an assumption. There are also assumptions about normally distributed data, but there are also some tests that don't have that assumption. So when you kind of look at your data and you think, I think I'm going to use this type of test, you can then go into the notes and see what the assumptions are. But pretty much everything's a simple random sample. So I really recommend, if you can do a simple random sample, do it. But it's not wrong not to do it. Then if you don't do a simple random sample, then you've got to argue about the limitations of that when you write up your capstone. David said, why in this case is it a random sample and not a simple? Which one are you which case are you talking about? Are you talking about comparing two uneven sample sizes? The answer to that, if it's that, if you're comparing two populations, it turns out that each sample has to be a simple random sample. I don't care what if the experimental design, should we write in future tense? I don't think really care about that. We've got more important things to worry about, looking at whether it's correct or not, or and how to help you, and to fuss about that. Yeah. Okay, but in this case, it's only one population. I don't know what case you're talking about. If you're talking about your own assignment, I can't help you. I'm not allowed. Yeah, sorry about that. So you can talk generally. You're talking about what's on the screen. Okay, thanks. Yeah, so this is one sample. That's right. They didn't do a simple random sample. That's one of the problems with this. Okay, thanks, David, for pointing that out. I wasn't clear what you were talking about. I think that's also a big problem with this so far. This is not the final answer. I'm doing it step by step. So this was still a voluntary survey and not really well done. However, I think later on talk about, that this is going to be a biased sample and why it's a biased sample. Okay, sample size, kept it the same. Here I said we did, okay, so I changed this a little bit. I think 229 is too big, by the way. I would have done smaller, but students were selected by drawing a random sample of 129 students and asking them to come to a meeting to fill out the survey. This is a way of getting around it being a voluntary thing, a voluntary survey, and having a more systematic way of doing the sampling. Yeah, so 10% is what's usually recommended, yeah, as the maximum. So that's correct, David, and Nura. So yeah, population of 200, yeah, probably a sample size of 20. Okay, what were the variables? Here I've listed them out a little bit better than what was done in the original. I think there was 7 ratings. They weren't very clear. I wasn't sure when they said 1 to 7 whether they meant the 7 ratings or whether they meant that each rating had a score of 1 to 7. So that was a bit unclear. Okay, so there were 7 variables: lecturer's competence, assessment, tutorials, lecturer availability, lecturer's approachability, relatability of the subject to the degree, and judgment of achieving learning objective. So they used a rating 1 to 7. Probably a 5-point Likert scale would be better, which is sort of like strongly agree, agree, neutral, disagree. Strongly disagree is what's conventionally used. So then way people have kind of a picture in their mind about how to rank, what number to assign to the ranking. Okay, Simon said, what if the population is from a continuous variable? Won't the population be infinite? How do you choose 10%? Nobody says you have to choose 10%. I said that 10% should be, you shouldn't really pick anything higher than 10%. So if you've got an infinite population, yeah, you're going to satisfy that no matter what your sample size is. So that's not a problem. Does that make sense? Yeah. Yeah, so that's good. Right. So of these variables, well, yeah, they're all ordinal variables because they're all rankings. In this particular study, didn't really identify which were response variables or explanatory. You don't have to do that because there are some statistical tests that don't distinguish. Many of you would have heard of correlation before, so you can look at whether one variable is correlated with another variable. So in that case, neither variable has response variable or an explanatory variable. So in some cases, you don't need to do that. But I find that for a lot of studies, it helps if you think of something as a response variable and the other variables explaining it. So, for example, if you're measuring some blood level of something, and that would be your response variable, but your explanatory variable could be whether you've taken a drug or a placebo. So some indicator variable would be the explanatory variable. So, if your study is in those sort of terms, then it's good to try and identify it. It also helps us figure out what you're trying to do. If it is correlation, does that mean both variables are independent? No. Correlation is that's what you're trying to find out, actually. So, correlation study, you're trying to see whether the variables are associated with each other, or are they related or independent. So that's what you're trying to judge. So that could be a research question. You could say, is the lecturer's competence associated with the assessment? Or, which is kind of crazy, probably wouldn't be. Or is the lecturer's competence associated with the lecturer's approachability? So there are different research questions we could have asked, but that's not the one that was asked. I worked out eventually that you could actually do this using t-tests, but with variables, you would have to do 7 times 6 comparisons to try and figure out which is the higher rating. So that's 7 sixes is 42 different comparisons. So that's, yeah, a t-test is just a test that's used to compare two populations. So using 2 samples, you try to judge whether whether the mean of one population is bigger than the mean of another population. So that's a t-test. And correlation people have heard of before, so that's just testing whether the variables are associated. So although they're ordinal variables, there are methods that you'll learn about, non-parametric methods that can cope with ordinal variables, or it's quite reasonable in these sort of studies to just treat them as continuous variables. And it's a limitation that you would discuss in your kind of conclusions in a capstone, but it's an accepted thing to do. Yeah, the response versus explanatory, yeah, that's the variable type. Technically, the variable type means whether it's nominal, ordinal, or numeric, or discrete and continuous. That's what's normally meant by the variable type. I said that it was probably good if you can tell to also indicate which is your response variable, which is your explanatory variable, if that's relevant to your study. If it's not, that's fine. That will just help us figure out what you're trying to do. So we're not going to take marks off if you don't put in the response and whether it's a response or explanatory. I wanted to originally, but then I realised there are certain tests that don't distinguish. So yeah, so that's more to help us just figure out what you're doing. As you can imagine, we get some tests where people think they're clear, but you read them, and like this one, the initial one, you just think, what are they trying to do? How are they going to do it? It can be really hard. But not only is this a challenging assignment for you to do, it's also a challenging assignment for us to mark. It is really hard to mark. Okay, so variables. It's also a good idea to mention some other variables, or to record some other variables. So you could record the gender, or maybe like a prior achievement level, because they could be possible confounders. So for example, you might find that all the students who have achieved, high distinctions in a previous subject really rate this subject, or rate the lecturer a lot better than people who have maybe failed it, or just passed. Well, won't be anyone who failed it before, because they wouldn't be doing it probably, but although it could be. So, some sort of prior achievement level, you could group them into distinctions and high distinctions and passes and fails, or some grouping you could decide. That might be a good thing to record. There are probably other ones that you might think of as well, other things you might record that you think could affect it. Unfortunately, in this subject, we can really only analyse not too many variables, only usually a response and explanatory variable is generally what most of the tests do. I think one test can analyse two variables that like a correlation, but where none of them are decided to be a response or explanatory. But pretty much you're really limited to two variables. Now in stats you can actually do lots of variables, but it's not within the scope of this course. So why record other ones? Just because it's good to see. You might end up changing your mind once you see, oh, there's a lot of variability, you know, amongst genders. Maybe, you know, all the females really liked that lecture and all the males didn't. So you might decide to change your research question because of that, and change your analysis. So that's why it's sometimes good to collect a few extra ones. Or you could change your population, say, oh, there's so much variation between the males and the females, it's kind of masking any other signal. So I might just take my survey and just do the survey on the females only, change my population to what the females think about the lecturers. So these give you a few options if you collect some extra variables. That's the main reason for doing it. Okay, treatments, grouping structures. So the comment here was there are no groupings of the students within the data because the research question is not comparing groups. So that was my explanation for that one, the way it was set up. Reducing sampling error, that wasn't addressed here, but in my fix-up version, I'll address that. Possible biases could occur if some students invited don't participate in the survey. So we tried to remove volunteer bias by kind of randomly selecting students and inviting them to a meeting, and don't tell them what the survey is going to be about, but put them there so that we're not getting bias which might occur if we weren't doing that. We might have got bias where only the students who had a gripe with the course did the survey, or only the students who really liked the course did the survey. It could be biased that way. Okay, Eamon said, is there a difference between treatments, interventions and grouping structures? Yeah, treatments, well, that's defined in the notes. So treatments are, interventions are something that you do that's different. So observational studies, you don't really do an intervention. So you can say that there's no intervention because it's an observational study. Treatments are just something that different people, different groups get. So if there are no groups, there are no treatments. Also, if you're kind of doing stuff with continuous variables, it kind of doesn't make sense to talk about treatments. So you just need to address that. Michael asked, a treatment is an intervention though. Yes, treatment's an intervention. No, treatment isn't always an intervention. The treatment can just be, in an observational study, you can have a treatment. Some people some people were smokers, some people were not. Smoking would be the treatment, but it's not an intervention because you didn't choose it. You didn't decide which ones smoked and which didn't. So there's a bit of overlap between the two, but they're not quite the same. Sorry, I don't think I can fix the problem. I don't know. Maybe I'm just changing things too much. Okay, I'll try not. It's probably annoying. Yeah. I think I had a cushion near me and I was moving it, so I think that's what was causing it. Okay, we're spending a lot of time on this one because this is the hardest one. The other ones will be quicker, but let's, yeah, right, so let's move on. Yeah, from the point of view of an assessment 2A, that was a much better one. And probably wouldn't have lost too many marks, only probably for they didn't address the sampling, the procedures for reducing sampling error. I still think it has some problems. in terms of going to the capstone. So the kind of, in terms of the feedback we'd give you. Yeah, my concern is there's too many variables. It's just not immediately clear how these variables will be used to answer the research question, but we don't, we don't expect you to know that if you don't know the test yet, but yeah, but that is an issue. Perhaps the research question can be changed. So some modifications are consider a new research question that asks if the two ratings are associated. So, some sort of correlational study could be an interesting thing. How much does is the lecturer rated, the rating of the lecturer independent of the assessment, for instance, or are they associated? That's an interesting question to ask. Another one is we can make some groups and we could compare the ratings, just pick one of them, for instance, or we could take all those 7 ratings and just average them. Once we've converted them into a numerical scale, we could just average all the 7 and get an overall rating, or we could just pick one of them, say the lecturer rating, and say we can compare the rating to 2 groups of the population, for example, gender. We'd say, do the females like this lecturer more than the males, or are they the same? Or if we had the data, we could compare a 2009 survey to a 2008 survey if we actually had it. We've already collected the data, then we may not have it, but that would be another type of research question that would involve modifying what we've collected. But we might ask, is the lecturer rating in 2008 different to the lecturer rating in 2009? And there may have been something different that the lecturer had done, or might be a different lecturer, or could be they've used a new teaching method. And so you might want to find out, well, what effect has that had on the lecturer rating? Does that make sense of kind of things that you could do? You probably also have your own ideas. Although this was a pretty terrible experimental design, it makes you think a lot and about how to fix it up, and there are lots and lots of ways. This is just 3 that I mentioned here. So what I've tried to do in the next slide is I've tried to rewrite it. So approved version, second attempt, alternative 1. Okay, just before I get on to that, David asked, if testing results, do you have to provide evidence in the experimental design? I don't quite understand. If testing results, do you have to provide evidence? What are you asking exactly? Could you jump in, or somebody could jump in who understands that?
Yeah. So my question is, if you taking some information, you're testing that in your experiment. So there's been a claim or whatever, and you're testing that in an experiment to see if that actually flows. Do you have to give evidence of the assumptions that this tested or where this test is?
Assumptions of where the test is.
In other words, evidence of a link, or evidence of this is
no place for it.
They make a claim. Do you have to say where that claim was made, etc.?
Sorry, can you say that again?
So an organisation makes a claim of, so they're going that they produce X number of chickens, right? Or they farm X number of chickens, right? And you got to test that, right? Somewhere else. Do you still, in the experiment, you have to give evidence of where that claim was made and why it was made?
Not in assessment 2A. There's no place for it. But in your capstone, there's an introduction and things like that. So you'd provide a bit of background to where it came from. I think, is that what you're asking?
Yes.
Yeah, so the place for that, so the answer to your question is in the capstone, you would provide something like that. Certainly the background But there's no place for it in assessment 2A. This is just the actual design aspect of it. Does that make sense? Does that answer your question? I hope that's clear to everybody. Yeah, so that answers it. So I think that's clear to everybody now. If the data set has 10 types, however, the question is related to variables. Is it okay for what does 10 types mean? You mean 10 variables? Sorry, 3 variables. What's the 10 types got to do with it? 10 variables, yeah. Well, yeah, okay. We would say to you, you're not going to have any chance of being able to achieve anything in your capstone more than likely with 10 variables, unless you know that you're just collecting those variables as possible confounders. You should probably, for us to give you good feedback, you would need to tell us what you think is the response variable and the explanatory variable. Otherwise, yeah, that lets us know whether you kind of line things up properly with your research question, and then which other ones you will just list as possible confounders. Oh, okay, so all right, so Michael's trying to clarify that question. There's 10 variables, we only want to look at 3 out of 10 of them. Well, generally speaking, you probably only really want to look at 2 in terms of a statistical method, rather than 3. It would be difficult to do 3, but it's still possible. You could look at all the correlations between, you know, if you got 3 correlation between 1 and 2 and 1 and 3 and 2 and 3 and compare them. So that'd be a possibility. But yeah, that's fine if you want to do that. You probably should, but if that's your plan, then you should put it in the experimental design. Okay, James said from the rewrite, suggested rewrite, 2 variables seem to be enough and preferred in this assessment. Yes, as I mentioned before, the only statistical methods that we'll learn in this subject involve 2 variables. We're not really going to do more than 2. We can compare more than 2 populations, but that's where your explanatory variable might have 3 levels. So, you know, that's fine. Should you still list the other 8? If you're intending the other 8 to be confounders, possible confounders, then it's a good thing to list if you plan to collect the data. Okay, in the real world, there's still going to be many confounding variables you don't even know about. Unfortunately, that's actually correct. You can't pick every one. You try to pick what you think are the obvious ones. If we look at your experimental design and we say that, you know, you should have considered this, and you might lose a mark for that if it's a really obvious one. But you're the expert at your design. It's just, I think, to show that you've thought about it a little bit about what the possible ones are. Michael said that's why you may use a control. Yeah, that's true. If you're doing an experiment as opposed to an observational study, you can use a control. The nice thing about it, confounders are not as crucial in experimental designs as they are in observational, because if you do random sampling in experimental design, it kind of it sort of randomly distributes over your possible confounders, and so you end up getting a better result. Can we see? Yeah, I'm about to move that. We just got a lot of questions, so yeah, we're still talking and can do that. So yeah, so variables, in this case, if we chose the lecturer rating, that would be the response variable, which is ordinal, but I'll put a little footnote that I'm going to treat it as numerical, but you don't need to worry about that for this assignment, but you will have to for the capstone. Although not necessarily, you can still treat it as ordinal. It's just a note that it's possible. It's fairly accepted practice to do that with surveys, although I personally think it's a bit dodgy, but lots of people do it. Explanatory variable in this case, oops, did I get the right one? Alternative one, oops, no. Okay, I have to change that. So I copied and pasted and then didn't change. So this would be year. And that would be basically a nominal variable. So what I'm really doing there is I'm comparing two populations. One is the people who did the population is the class in 2017 and the class in 2016. Are we going to ask a question requiring correlation, or should we stick to comparing means? We're teaching correlation, but it's not till week 6. So if you're going to do that, probably you're going to have to read ahead. On the other hand, we're comparing means in week 4. So yeah, if you have that choice, you might, and you're unfamiliar, you're new to stats, I would probably stick to comparing means, just because you'll learn the techniques earlier. But it's quite all right to do correlation or regression studies, but it's not till week 6 that we're doing that. Does that answer your question, Kerry? So you can do either, but yeah, don't overcomplicate it. Exactly, that's the idea. It's the hard thing about this assignment is it's very easy to overcomplicate things. Okay, so let's breeze over this, because I've taken almost an hour discussing this one example, which is amazing, but there's a lot to it. Treatments, grouping structures. The treatment would be something different that's done in the teaching. Could be new lecturer, different way of teaching. Hard to know because we don't know the mind of the people, but they're examples of things. The two groups are the 2016 cohort and 2017 cohort. Reducing sampling error. Well, yeah, increasing the number of students doing the survey. You'll notice that in this case, I only picked 30 for each group, for each year. So that was a bit more reasonable. It's actually probably still a bit high, but it's within reason. So you probably wouldn't really want to. I think that I wouldn't be increasing it more than that. There will be some. This is an interesting one that you might not have thought of. There will be some potential pseudo replication, as some students might. I won't say will be. Might be being the subject. So why is that a problem, repeating students? Kind of asked this question in the discussion forum in a little bit different context. So anyone know why that's a problem? Why it's pseudo replication? Yeah, that's one way of saying overrepresented, or basically I'd say then that the two samples are not independent. Because if they contain somebody who has, who did the subject the year before, and they're being sampled twice. So yeah, it's what's known as pseudo replication. You're replicating something, you're using the same experimental unit twice. So Yvette did a nice video. I don't know if you saw it on pseudo replications. I recommend you have a look at that. If you have two nominal explanatory variables with each with 2 levels, does that mean you have 4 grouping structures? I suppose that's true, Aman. But I would just say I've got 2 grouping structures for each variable. Reducing bias. In this case, yeah, it looks like it was volunteer, although it wasn't clear. So if it was volunteer, there could be considerable bias because students who volunteered to take the survey were highly positive about the subject or highly negative. So it's not things in real life. You sometimes have bias surveys. The important thing is that you know that it's biased and you can discuss it as a limitation in terms of your conclusions in your capstone. So, if you're forced into it, then the world's not perfect. It's great if you could do a simple random sample for everything, but yeah, sometimes you can't. So in my next example, which I'll kind of whiz through, of course, I'll post these so people can read it in detail later. This one I did, research question, is there a difference between male and female students' rating of a lecturer in a maths subject in 2009? So you notice I'm being fairly precise. I should really, instead of just saying a maths subject, I probably should say what university and, a bit more precise about that. But I'm saying what year it's in. So my population's all students in this maths subject in 2009, and bracket size equals 200. Design types observational. All students who took the survey, I'm saying maybe 40 people. And here I'm saying students were selected by drawing a random sample of, change that to 40 students, asking them to come to a meeting to fill out the survey. So that's trying to get rid of some of that volunteer bias by selecting them first and then inviting them to the meeting. Maybe not everyone will come though, so it may not be perfect, but still better than just having people volunteer, I think. Variables, response variables, they'll say lecturer rating 1 to 7, ordinal, or treated as continuous. Explanatory variable, in this case, is student gender. Other possible variables may be prior achievement level. Treatments, grouping structures. Yeah, so in this case, the treatment is really just whether it's gender and male and female, and it's also the grouping structure. Reducing sampling error, same as before. Lack of independence of samples could occur if repeating students are sampled twice. Could exclude repeating students from the population. So you could just change the research question to say, only students who are not repeating. And then you get around all that problem. But depending on, if you only had like 5 repeating students out of 200, then maybe you would just not worry about it and you would argue that that's not going to contribute much, although it's pseudo replication, it's only small. On the other hand, if you're perhaps a really bad lecturer and you had 100 students repeating, then that would be a problem. Okay, a couple of questions. One question, David. In the example of a clinical trial with a control group versus a group who took the medicine, is the grouping structure the ones who had the placebo versus the ones that had the medicine? Yeah, that's right. That's correct. That's the grouping structure indeed. And the treatment is the whether they've had the the type of medicine that they've had. I find this treatment grouping structure is a bit strange because it's kind of a bit repetitive. You've already kind of said it in the explanatory variable. And it also seems a bit kind of directed towards studies like a clinical trial. And for some studies, it doesn't make quite much sense, but then you have to say why that's the case. Bias, I think I've said that before. Yeah, so one thing, possible bias could occur if some students invited don't participate in the survey. Also, some selected students might not wish to participate. This could be partly avoided, I shouldn't say completely, partly avoided by not informing the students of the purpose of the survey prior to them doing the survey. That might sound a bit cruel, but maybe they won't come. So you might have to offer them some money or something like that to come. But what would be better, to have a survey of, say, 30 students where you have to pay for chocolate versus a survey of 160 students that just volunteer to do it. I'd rather pay the money for the chocolate and have something that's more statistically valid. So that's why some surveys, they offer prizes. Okay, gone past 8 o'clock, so I'll just whiz through these second ones. Do responses need to be, I don't really care. Mine aren't, so fine, yeah. I personally prefer dot points and simple because it's less for me to read. So yeah, there's no requirement that things have to be in complete sentence. You know, some of my things were in complete sentence where I'm explaining something a bit more complex, but list of variables, I think it's easier to read if a list of variables are kind of dot points. So part of my sneaky reason for doing this is to kind of show people a nice way of laying it out that makes it easier for us to mark. So that's my secret agenda. Okay, let's just briefly look at the other two questions. Karen's asking something. I missed getting the survey in on time. Is it still possible? What are you asking? Sorry, is this a kind of, are you asking a question there, Karen, or is this a comment or what? Yeah, thanks. Just wait for it. Oh, you mean for the quiz? Yeah, you can. I think the quiz is still open too, so if you do it, you just have a mark deduction. Yeah, 5% per day. I would have preferred that we closed it, but anyway, that's what it is. So yeah, and it's only worth 10%, so it's not a big deal. So yeah, I'd just get stuck in and do it. You won't lose much. Sorry, when you said survey, I was a bit confused because yeah, I thought you were talking about this survey. So sorry about that. Okay, let's just briefly look at this one. More sorting out what the problems are. Does assessment speed slow down in the evening compared to midday? Population internet speeds from residential homes in Australia. Sample of internet speeds. Sample was taken between 12 to 1 and 100 taken. I think I think I left out 100 here. Something like that. It may have been the same. Yeah. Yep. Sample size 100 internet speeds for each time frame. Okay. Variables, the internet speed in megabytes per second, which is a continuous variable. Grouping structure, data split between midday and evening times. So what problems do we see with this one? Yeah, okay, that's actually, David said sample and population don't match. Yeah, so there's really, firstly, is the research questions again a bit vague. It's not too bad, I think, but you know, maybe that's okay actually, research questions, sorry. Yeah. Oh no, I know what's wrong. Okay, things don't match. The internet speed, they're talking about all internet speeds. I don't know if they mean in Australia, the world, in Melbourne, not really clear. Population, internet speeds from residential homes in Australia. Okay, here they're defining their population, but it's not kind of consistent with the research question. Sample of 100 speeds taken from his own house. If he's taken speeds from his own house only, how can it infer internet speeds for all residential homes in Australia? So that's a big problem, okay? That's what somebody mentioned earlier, I forgot who it was, said the population and the sample don't really match. So that's really the main problem with this one. And The other one is, not clear how the sampling was done. Populations poorly defined, and also some of the rubric elements weren't addressed. So they were the main problems. And just very briefly, I won't go through everything, but research questions changed. Does internet speed slow down in the evening, bracket 7 p.m. to 8 p.m. compared to midday, 12 p.m. to 1 p.m. at my house? And then population, oops, I've typed the wrong thing in there. I'll fix that later. It should be internet speeds. So there's two populations. I would put an S in there. Internet speeds at my house from 7 to 8 p.m. and my house from 12 to 1. So there's two populations. Yes, Michael, I said earlier I was going to post them to the discussion board. You'll find them under where I announced this collaborate session, so way down at the beginning of the week. Okay, so the sampling, I said two simple random samples, size 100, were done between 12 to 1 p.m. and between 7 to 8 p.m. by randomly selecting 100 times in each of the time intervals from a list of times corresponding to each minute in the hour. So the way I would have done this is I would have probably made an Excel file and just had 700, 701, 702, 703, 704, all the way to 8 o'clock, another one from 12 to 1, and I would then use R to generate a random sample of 100 of the first time and 100 of the second time. And they would be simple random samples then. You don't necessarily have to do it in minutes. You could break it up into 5-minute groups. It probably doesn't matter a great deal. 5-minute might be reasonable, but I am wanting to get a sample size of 100, so I would need, maybe I would need really, even breaking an hour into minutes won't be enough. So maybe I should have taken a smaller sample size. Might have been better. Is the population incomplete in this example? In what sense, Daniel? Possibly. I'm not saying I get 100% in this assignment. Yeah, you probably could be more nice, but given that you say it's at my house, then it's whatever the internet they're using at their house. So it's kind of not ambiguous. Might be nice to say, to spell it out a bit more, but I would accept something like that, if that makes sense. Is that kind of what you were getting at? Yeah. Yeah, because it ties it down. Even if I don't know what it is, at my house, whoever the person who wrote it, what speed it is, it doesn't affect. That's making a few assumptions, but yeah, you don't want to overcomplicate things. So it's a balance between getting rid of the vagueness to keeping it concise. Okay, I think you can read the other bits. Let's have a quick look at the other one. I didn't address the sampling error, but yeah. Okay, test of a new drug's effect. Original version. Does a new blood pressure drug keep patients at a different blood pressure? New drug keep patients at a different blood pressure to the standard drug. I had to read that a few times before I could figure it out, but it's not a great research question. Blood pressures of everybody taking the new drug and everyone taking the old drug. Who's everyone? Everyone in the world? Gee, and yeah, maybe that is consistent with that. But then they sampled 50 people from prostate cancer clinic take the new drug, and 43 people sourced from a breast cancer clinic take the old drug for 2 weeks. So the population their population isn't really consistent with their sampling, and they didn't really give much detail about how the sample was done. Did they do a simple random sample or something different? I just don't know. Okay, so yeah, so that wasn't terribly clear. I think you guys talking about internet are kind of distracting everybody else, so I think it's not really that relevant. Okay, what other problem do you see with this? So maybe we got to compare, its populations. So maybe one population is the breast cancer clinic, and the other population is the prostate cancer clinic, and maybe it's got to be between a certain time. So yeah, so prostate cancer clinic is all males, and the breast cancer clinic, well, would probably be mostly females, but maybe some males. So there's a kind of problem there. How will we fix it? Well, we would my advice to the person who wrote this would be just to focus on the prostate cancer clinic only. And then also, my groupings are those who get the new treatment, the new blood pressure drug, and those who get the standard drug. So there's two different types of drugs. So that's the grouping I'd be looking at. They didn't say what the grouping was, but yeah, but that's the grouping I'd be looking at. So the variables is not terribly informative. A little bit, it's talking about how kind of how it was done, but it's not telling me what the actual variables are. So, I'd much rather see just things listed rather than a paragraph that's not really helpful. Yeah, so David said males can get breast cancer too, can't they? Yeah, basically that's what I said, that the breast cancer clinic would probably be mostly females, but could be some males. And that's fine. You could just focus your attention on that clinic as well. But maybe you would record the gender in that case as a confounding variable, possible confounding variable, because the responses may be different. More than likely, maybe the drugs would be the same either way. So they're the problems, and kind of here's basically the solutions. Which cancer drug is more effective for male patients at a, just say particular, I don't know which it was, but a particular prostate clinic, and I should have put from May to whatever the period was. Yeah, okay, it's said here from 1st of May to 30th of May. Okay, oops, undo. Study type looks like this was experimental, though not really clear. Mark against that, because but depending on how they've done the sample, yeah. So if they've done it the way that I've said in the sample, then it's an experimental study. A simple random sample of patients was obtained from a list of all patients at 1st of May. Patients were randomly assigned drug A or drug B. Okay, so important thing is, yeah, so Nuru said collected data, it's not observational. Yeah, it's because we're manipulating the variable of who gets the drug and who doesn't. We're deciding. If we just asked people to record what drug they were using and they chose, that would be observational. But because we're choosing, that is what classes as experimental. The response variable in this case is the average blood pressure. Should probably say what units it is to be precise, but measured 3 times a day before meals, and averaged, I think. Peter asked a good question. If I'm doing an experiment at home, should I include in the research question that the item is from my home? Yeah, it's a hard one to answer. I think probably to be safe, I would, because because that's kind of, yeah. Can you get marked down for being too explicit? Only if you're contradictory, I guess. So yeah, Peter, I probably would say it. I don't think we'd fuss too much about that, but yeah, I have to think about that. I think it's probably okay. You can probably generalize to some extent as well. If you're using kind of like standard ingredients or something like that, or standard materials that, although they're not picked randomly, they're regarded as identical. But if you want to cover yourself, I'd probably say that it's in your home. David asked, can you be marked down for being too explicit? Probably not, but also you need to be concise as well, so you might be marked down for that. So yeah, I have to go too, I think. So hopefully that helped a bit. I'll just have a look at that. I'll post it probably tomorrow morning. But anyway, I think we better stop now. I've gone way over time. And hopefully that gives you a bit of an idea. Yeah, don't worry too much about it. But, you know, although this is worth 10%, its primary value is in feedback to the capstone. It's a hard one for us to mark, but actually it makes the capstone easier to mark. So, so that means it's doing its job. Okay, so I'll just end the recording now, and